Hey folks, it's Pat here. Got another request for a chapter 6 problem, and that's going to be this guy right here. Binomial problems, basic. Now remember, with all our binomial problems, we're looking basically for the same thing, which is, first of all, what can happen and what's the percent of, or what's the chances of any one of those individual things actually happening. And so there's a couple of different ways to do these, but I'm going to show you a pretty cool tool that I want you to start using today. Now, like some of these with the basic ones, they basically come in two flavors. So there's really easy ones and there's ones that are a pain. Okay. So, and they're not hard. It's just the math. There's a lot of ways to screw it up. So let me show you how to do this first with the Alex calculator. And then I'm going to show you a cool tool that'll actually make your life a lot easier. All right. So here's an example. TV executive is interested in the popularity of a particular cable TV show. I was told that 65% of American households would be interested in it. So if this is correct, what's the possibility that all 6 of the households in her city being monitored by the TV industry would tune into the show? And so the first type of problem that you're going to find is either all or nothing. And with those, all you have to do is just take the probability of one household liking it and multiplying that by the number of households that you're looking for. And so that's pretty easy here with the Alex calculator. All right, so you can just take this one, and so it's 65% chance that each individual household will like it. And then you can just take that and multiply by how many households there are. And if it was like not liking it, then you would just do the opposite of that. You would do 35% chance, okay? And so there's 35% chance that none of them like it, okay? So punch that in there. You get this guy right here, and we can go ahead and stuff that in here. Just make sure that you round it correctly and give that a check. Ta-da! All right, so those are the easier ones. There are other ones that are a little bit more difficult. Let's see if we can find one of those. And those are the ones where you actually have to have a combination in it. So like this one, New England Colonials baseball team is equally likely to win a game as to not win it if 4 Colonials games are chosen at random. What's the probability that exactly 3 of those games are won by the Colonials? Now, let me show you the explanation on this one, just because I'll show you the difference between a problem like this, where it's like out of 5 choose 2, or out of 4 choose 2. And the difference is that you'll actually have to do a combination first right here to figure out what to actually punch into that formula. All right. And if you click on the binomial formula, it looks like this really intimidating thing, but it's really not that bad. But you don't really have to worry about it that much, because the place where most people screw up is in figuring out the combination first. So this would be out of 4 choose 3. So you could do it with using the combinations formula in Alex and doing the Alex calculator, this whole junk that you all saw back in combinations. You don't need to do that. Okay, this is going to make your life a little easier today. So let's find another problem that's kind of like that, and I'll show you a tool that's pretty cool. Let's see what we got here. Neatest fast food chain specializing in hot dogs, French fries, blah, 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 blah. So 52% of customers order their food to go. Proportion is correct. What's the probability that in a random sample of 5, exactly 3? So this one would have a combination. So it's 5, choose 3. Let's just use this guy here. So go over to Blackboard, and in Module 2 folder, you'll find a link to this guy, which is on StatTrack, the binomial probability calculator. Any stats calculator worth its salt will actually have this in there. So, but you don't have to worry about it too much, because there's no calculator like that required for the class. So you could just use this one. And so this one will do all the basic problems, all the advanced problems, and it's pretty dang handy. So just use it. You just need to pull information from the problem and plug it in here. And so it's going to ask you for 3 things. What's the probability of success? How many times are you going to try it? And how many successes are you looking for? Okay, and so let's go back to our problem here real quick. So probability of success reports that 52% of its customers order their food to go. So we're looking for people ordering their food to go. So 52% is our success rate. And so we just plug that in here, .52. We're going to try it 5 times. And how many were we looking for? Was it 2 or 3? 3. And we're looking for 3 successes. So let's just go ahead and do that. And then hit calculate. Don't hit any other buttons on here. You might open mortgage. And ta-da, it gives us this probability. Now, when you're looking for exactly the number of successes, it's always going to be x equals x. So exactly in this example, we are going to get exactly 3 times, which is our little x. And so that's .324. Got to do the rounding right. Otherwise, Alex will yell at you. .324. Let's go ahead and give that a check. And there we go. We got that one right. All right. So this thing, the StatTrek binomial probability calculator, start using it. It'll solve all the basic ones. It'll solve all the advanced ones. And it's totally fine if you use that. You know, it makes your life easier. Knock yourself out. So hope that helps. If you have any other questions, please ping me. Otherwise, we'll see you down the road for additional topics in the near future.